These are the notes for the 1.3 to 1.6 remediation relearning video and the quiz retake. So I invite you to follow along with this remediation video. You can solve the examples along with me, take whatever notes in addition that you'd like to take, and then once you're done, you can go ahead and turn to the next page, and those will be the actual retake questions for you. You can use these notes to help you work through those problems. Turn it in to me, I'll grade it, and whichever grade is higher, this or the original quiz, that's the grade that will go in the grade book. So let's begin with the notes. So number one asks you to simplify the expression. Important to keep in mind when we talk about simplifying, an expression is completely simplified when there's no parentheses that need to be distributed and all like terms have been combined. So I can see here that I've got to distribute the 3 across the 6 and the 7n. So 3 times 6 is 18. 3 times 7n is 21n. And then I've also got a negative 5n. So now that I've gone ahead and distributed across those parentheses, now I can go ahead and combine like terms. So recall that we combine like terms by adding or subtracting the coefficients on those like terms. Same variable, same exponent. So I've got a negative 5n and a positive 21n. 21 minus 5 is 16n plus 18. Now I look at 16n and 18n. There's no longer any parentheses, no distributive property is required, and I no longer have any like terms. Same variable, same exponent. So 16n plus 18 is fully simplified. So when we simplify, we make sure that we distribute across all parentheses. And combine all like terms. All right, so continuing to combine like terms, an opportunity to apply it. So we're going to write an expression for the perimeter of a rectangle and then simplify that expression that we write. So let's keep in mind that if we're doing a perimeter of a rectangle, I have length plus width plus length plus width. Another way to think about that is perimeter is 2 times the length plus 2 times the width. So I have a measurement, 3x plus 3, that I'll label the length, and 2x plus 7 that I'll label the width. So writing my expression, perimeter equals 2 times my length, 3x plus 3, plus 2 times my width, 2x minus 7. So now I've written that expression. Now my job is to simplify this expression. So 2 times 3, 6x, plus 6. Here, 2 times 2x is 4x, 2 times negative 7, negative 14. So let's combine our like terms now. 6x plus 4x, all constants are automatically like terms, so the 6 and the 14. 6x plus 4x gives 10x, positive 6, negative 14. That's a minus 8. So this is the answer for simplifying. So here's my expression for the perimeter. This is my work to simplify. Next, we're asked to solve. So simplify means combine the like terms and distribute. Solve means value of the variable that makes the equation true. Now remember, we have 2 tools to do this. Inverse operations, undo whatever's been done to the variable, and properties of equality, I need to do that on both sides. So I look at this equation, I see that it contains fractions. And we can do this a couple of ways. We can do this by brute force, just subtract 1/3 from 3, and then clear out my 1/2. But another way, maybe a little less stressful way to do it, is to clear out the fractions. We're going to do that by multiplying by the LCM of the denominators. Which in this case is 6. So 6 times 1/2. Half of 6 is 3, so 3x. 6 times 1/3. 1/3 of 6 is 2, and then 6 times 3 is 18. Be sure to multiply both sides of the equal sign. If I multiply by 6 here and here, I have to multiply by 6 here as well. So we'll subtract 2 from both sides. I have 3x equals 16, divide by 3, and x equals 16/3. This is an acceptable answer. You don't need to change that into a mixed number. You can leave it as an improper fraction. All right, so our last example, writing a verbal model for a word problem and then translate into an equation and solve it. So we have a 20-foot diameter swimming pool filled with water to a depth of 18 inches. The garden hose flows at 6 gallons a minute. We're asked how long it'll take to fill the pool to a depth of 4 feet. We're also given a conversion, cubic feet to gallons. So thinking about what we're doing here, we've got a circular swimming pool, and it's filled with a certain amount of water. We're trying to fill it this distance. Well, what are we talking about here? We're talking about volume. So we need an equation for volume. So volume is, well, let's think. The radius squared times pi times the height of the cylinder. So that's our verbal model that we can use. Now let's translate it into an equation. So the volume is pi times radius squared times height. Excellent. Let's go fill in some of these numbers. I have a 20-foot diameter, which means my radius is 10. Pi is a constant. Now the height. We want to kind of step carefully here. We're told that there's already 18 inches of water in the pool, and we need to fill it to a depth of 4 feet. So we also have diameter in feet and depth in feet. So let's go ahead and convert these inches into feet as well. So 18 inches, 12 inches is 1 foot, so that's 1.5 inches. 4 minus 1.5 equals 2.5 for height. All right, let's keep moving now. 10 squared is 100 times 2.5 times pi. So I'm going to move the decimal 2 places here. That's 250 times pi, and this is cubic feet. Okay, well, great. I know cubic feet, but we're talking about gallons in terms of my water flow. So we'll also need to make some conversions here. Let's start by figuring out how many is 250 pi. So 250 times 3.14 gives me 785 cubic feet. My conversion says that every cubic foot is 7.48 gallons. So I need to multiply. So I have 5,871.8 gallons. All right, so that's a start. I know I need to fill 5,871.8 gallons. And this can happen at 6 gallons a minute. So let's divide that. 978.63 minutes, which is fine, but that's not really the way that we talk. So what is that in terms of hours? So we take the 978.63, divide by 60. So 16.3 hours, about 16 hours and 20 minutes to fill the pool. So now that you've done the practice problems and taken some notes, go ahead and flip the page over. You can use these notes to work through the 5 problems on the next page.